Okay, thanks. My name is Tyler Waring, and I'm going to be presenting today on CouchDB, Leaflet, and visualizing large data sets. Oh no. Okay, let's just play this thing. Large data sets through time series. I'm going to be jumping around a lot out of this presentation, and I hope you all like code reviews. Okay, so what we have here is the abstract I wrote for this. I wrote this back in August in kind of that magic hour after my third cup of coffee in the morning. And, you know, there's a lot of words in here, many of them technical, strung together with some other words and some punctuation. But if I was to isolate each of you and ask you what this was about, each of you would tell me something different. And so what I'm proposing is that, you know, basically this may be something that is just too complex. You know, these words basically aren't to the point. Now, does anyone recognize who this person is? You can call out his name if you do. Okay, well, anyway, this is Charles Bukowski. And while I would not suggest quoting him often in a professional setting, he did say this, which I thought was really important for today. He said, an intellectual says a simple thing in a hard way. An artist says a hard thing in a simple way. So look around you today. We've got data analysts, we've got software developers, we've got database administrators, and I would say that we need to approach, when stepping out into the business units to develop something for them, we need to approach what we do more as an artist than as an intellect. We should talk to each other using high words and whatnot, but when it comes down to it, we should be able to communicate in a different way. And what I would suggest, let me jump to this slide actually, what I would suggest is that JavaScript and HTML provide an excellent means of communication. Rapid prototyping, getting ideas to the business units so they can basically have something that they can really sink their teeth into, may be more important than basically using large words, technical stacks, you know, things like that. So with all that said, let's just jump into today's use case. So this is what AVL data looks like. Typically it comes in a CSV file that would stretch from here to Charlotte, you know, often not headers. And in a typical file, you would have like 1.5 million, 100,000 points per day. So this presents a huge problem for visualization, analytics, things like that. Basically, latency becomes an issue, and traditional out-of-the-box software solutions, I struggled with having those display correctly, or actually being able to implement what I wanted to see. So basically, we're dealing with large volume queries. If you're not getting more than a day's worth of data, or a day's worth of data at least, then you're not really being able to show any kind of interesting trends. So this was something I developed in my free time, and you know, it was basically to try and come up with a solution to get information from the database to the client. Again, these are the stacks that I use: Leaflet, CouchDB, and D3. And you'll notice there's a small elephant on this slide that I think we need to discuss, and that's Postgres, because I would not suggest doing any of this the geodatabase stuff in CouchDB. It's time intensive. It's going to take a while. You can do a ton in Postgres. But what I want to know is, I want to see a cage match between Postgres and CouchDB for serving up this information once it's processed. And if I can make a query of the server and have that return 2 seconds quicker in CouchDB, then I think that's a compelling reason to have two databases. So I am building out this in Postgres as well. It's just not ready. So let's keep on going. So how do we do this? For import, we're going to use this nice package called Couch Import, which is a command line tool. You can get it out at NPM. So let me jump out of here real quick. Go here. Couch Import, go get it here. Do your global install, and then you got it. So let's go into terminal real quick. I always like to go directly to CD directly into my, my data location just makes it easier. So here's the call right here using couch import. It's a cat call to my data file, which is test points. Couch import is the package. The database that it's going to is February 23rd. It's a JSON file, GeoJSON, but same thing. And then this is where I find it's going to be, this is a really useful package, is to specify the JSON path. And so I'm wanting to query these in CouchDB, right? So I need to separate these files and hold them independently so that I can query them based on any date range. So by specifying JSON path, what we're actually doing is saying, pull in each one of these records into their own separate document. In that way, we can put indexes on them, and we can query those documents. So let's just run this real quick. I've got a little sample file. Let's see, where is it? Right here, it's got like 300 points in it. So this is your typical JSON file for AVL data. Okay, so boom. It's going to do it pretty quick. So now let's jump over to CouchDB, or actually Futon. February 23rd. We've got 312 records. Wow, this screen's really small. They look like that. Now you'll notice in here our time is a string time. And I left this in here purposefully to kind of exhibit how we can manipulate documents within a CouchDB using some Python scripts. Now strings are great. We can look at them, we can read them, but they're utterly useless if we're going to quote unquote do the maths on them. So let's jump over to our slides real quick. So here is what we're going to use to do that. It's a CouchDB Python library. You can find it right here. And, okay, back out. And so this is how we use this. I've imported, well, let's actually go over here real quick. So you can find a lot of information here on how to get this, this library and then how to implement it. And so let's go over to PyCharm here. And I'm just going to walk through this real quick. We're going to import CouchDB time and date time libraries. Now here we're going to create an instance of our CouchDB server. And from that server, we're going to create an instance of our February 23rd database, right? Now, for every ID in the database, let me just jump over there and show you. Every ID is unique within a document, right? We're going to loop over. And now we have to put this little clause in here to look for AVL time, because everything in a CouchDB database is a document. So that could be you know, a design document or a view or something. And so if we don't specify or find a way to basically classify what kind of document it is, then we're going to be running calls on documents that are going to cause this to fail. So we're basically wanting to look for, let's jump back here, for this in our document. Then we know that we can run this process on it. Where was I? Okay. Now, when we go in here, we're going to create a text time variable, which is our instance of that text string that shows the time. We're going to create an epoch, or you know, how many seconds since New Year's on 1970 out of that. And that's great for doing math with. And in fact, I'm going to even convert it to a millisecond just because we often use that in JavaScript. Now we're going to create a new document property called ms time, which is milliseconds time. And we're also going to create something called a geo class, which we're going to call AVL points. And the reason that we do that is because later on the CouchDB side, we can start to create views that call specific properties within the document. So anyway, oh, and this is the most important part. I've actually run this on 1.5 million records before and forgot this part, and then realized there were no revisions made after 8 hours of letting this thing run. So don't forget this part, very important. So let's just go ahead and run it. It's going to go pretty quickly. And then we're going to go back to CouchDB and refresh, and you'll see here now we've got something that we can use on the client side. So that's just an example of how you can deal with some of this data. Now we're going to go and I'm going to show you some quick examples here. So this is an application that I've got. I just put it out on GitHub, I guess, last night. Oh my gosh. Where are my buttons? Oh, it's too small, I bet. No. Oh, this isn't going to be good. Huh. Screen resolution larger, how? Okay, let me just try this all over again. You know, they always say never do a live demo. Now I know why. Okay, system preferences, display. Anyone know how to make the resolution smaller? 800 by 600? Control down? Control down. Thank you. Okay. Command Shift minus? You know what? There's something wrong here. Oh, you know what? Let's turn this thing off. Let's just close down PyCharm. Uh-oh. Yeah, let's see, command minus. The amazing thing is nothing's showing up in here. Sorry, this is inopportune. Okay, let's debug this puppy. Oh, internet connection, duh. Man, you know, you think of everything and then you don't think of internet. Okay, so what are we going to do now? Man, this is not system preferences. Come on, give them to me. That's not what I want. Okay. Does anyone know which one it is? This one right here. Okay. Okay, I'm going to try and catch up. Got to get to my Dizzy Gillespie quote. Oh boy. Okay. Hey, I really appreciate you for staying in the room, y'all. Okay, this is about to happen. Close it? Okay. Whoa. Oh my gosh, there's a map. Okay, let's get back into here as quickly as we can. Okay, file, live review. I'm gonna have to trim this down a little bit. It looks like I got 8 minutes left. Okay, I think we can do this. Okay, so let's jump over to CouchDB again. This is our application. We're calling this right now, these block groups, from a GeoJSON. So how are we doing that? Let's go back to our databases. Let's jump into Durham. Now, this is a document here. I'm going to actually definitely start to pass topo.json. Makes total sense. Here's just a GeoJSON. Now let's go back to our database. Let's go to our design document for picking out a geo class, and let's go and look at our view. This is how we basically go in there and query a CouchDB. So function doc if doc.geoclass, and this is why I like this geoclass property, equals Durham block groups, then emit or return that document and its geoclass. And so we're going to jump into the code here, and we're going to look for example 1. This is how it's done. We're going to grab this AJAX request. Let's throw it into a browser real quick and hit return. There's our GeoJSON. So that's how it's grabbing that. Let me close these so I don't get confused further. That's how we're getting data in there. Now, we're going to go a little step further, and we're going to start looking at some of our production data for this AVL. Now, this has got 1.5 million records in it. It each looks like these. This is a single feature, right? And we're going to query this and then create a GeoJSON layer on the fly on the client side. And we'll look into here. We've got, of course, our milliseconds. We've got a GeoID, which I was hoping to use but didn't have enough time. And then we've got a speed and a car ID, which I did make use of. So let's go back to the application and then quickly look at example 2. Okay, so here we're making that AJAX call, and I probably should jump over here and just show you how this works. We're going to go to AVL time. Here's our view. Let's go and look at the view real quick. So in here, we're going to say if document.pubTime, then so if the document's got a millisecond time, then basically return that document. And one of the cool things about CouchDB is you've got a start key and an end key that you can specify. And here I've got these hard-coded. Like I'm saying, this is a communication tool. We're not going to spend the time to put this into production. I'm just basically trying to convey some information to you all. So I've got the start key hard-coded. We'll query that, get a result, and then come down here to process map records. Here we're going to create a GeoJSON object. And then we're going to say, we're going to turn the features, which are here blank, and we're going to populate that with what was returned on our query. And how we're going to use that is basically this nice little library called underscore. And you go in here and you start to read about some of this stuff. Returns a wrapped object, calling methods on this object will continue to return wrapped objects until the value is called. I don't know what that means, honestly. And I get a lot more value out of looking at some of the examples. It's dense stuff. It's like Wittgenstein. If you can get through a page in an afternoon, count yourself lucky. But stick to it. It's doable. And definitely ask people and try and seek people that basically know a lot more about underscore than I do. So what this basically is doing, however, is saying for each result, for each row in that feature array, we're going to combine those into this GeoJSON's features. Once we have those, we've got our query layer, right? And this is where it starts to get interesting. We're going to set up our slider, again, with the hard-coded values, start and end date. And we're going to start to set up our SVGs and our D3 components. So this is standard D3 stuff here. It's also pretty dense stuff, but there's tons of examples out there. And just get in there, kind of switch something around, see what happens, and eventually you'll get what you like. Now, where it starts to get interesting is this brush right here is going to happen every time the slider handle moves along the scale of time between the beginning of the day and the end of the day. And so when that happens, and this is kind of like the interesting part here, it's going to go in there and then start to update the features that we have and only display the ones that satisfy the query or the query that's set by the slider, which is the instantaneous time minus or plus 45 seconds. Here we're doing some stuff to set the colors, and then basically that's it. Now, this is all out on GitHub. I encourage you to use this. It can definitely be extended to do some pretty cool stuff. Now, let's kind of show you what this thing does. Okay, so we'll turn off this. We'll turn on our time because this will show us, it's really small. Maybe Command plus. Okay. Okay, cool. So there's nothing in here. Again, this is not for production. This is for discussion. We're going to go ahead and query. We're counting. The slider will show up once the query is complete. It's going to return about 60,000 rows. And now we're going to push play. And so what you're looking at now is kind of the location of all of these vehicles. And I've gone in there and basically taken the car ID and given that a specific color so that you can differentiate them. I've also kind of changed the radii on them so that cars that are going slower have a larger radius, cars that are going faster have a smaller radius. And this is basically the crux of this application. Now, I've kind of started to use this architecture, and there's definitely a lot of ways, different places that we can go with this. You know, thinking of ways to aggregate this stuff on the fly, to say block groups, to think about ways where time in a certain area is spent. You can start to think of different really interesting visualizations that could be done, and then also component charts and graphs. So I'm going to kind of step into a smaller, lighter weight application. Let's see here. These are some of the things that I've used. This is a material design application. Basically kind of gives it its snappy colors. We're using D3 underscore and, of course, jQuery. So I'm going to go quickly and just kind of show where I've used this in a more professional setting for a municipal solid waste decision support tool. This is a free tool for simulating various waste management practices, generates a lot of great data. So right now it kicks out data, but we need ways to visualize it. So we're working to make applications and other kinds of visualizations. You can find more out about it right here. I'll show you that website. So this is a free tool. You'd be encouraged to go get it, generate some data, and then visualize it. So let's see. Here's the tool here, and it's basically pulling stuff from another CouchDB database. We've got configurations that we're pulling from the database. We're getting features and whatnot. And you can basically jump around and get information about different scenarios and how that tons per year can change based on different scenarios. We haven't quite built in the scenario selector, but I'm kind of envisioning like a bar chart at the bottom with a number of different scenarios laid out, and then a selection of that bar chart to kind of jump between scenarios. So let's see here. We can go over to charts. We've got a nice little chart here. Let's see. Okay. Got to get to my Dizzy Gillespie quote. So basically, this is just another visualization tool that uses the same kind of, okay, there's nothing in that one, uses the same kind of architecture. And let's get back to the slides. So basically, Dizzy Gillespie is pretty awesome in my book, probably one of my favorite. It's a really nice picture of him, too. He said, "It has taken me all of my life to learn what notes not to play." And I think that that's like a really important kind of sentiment to think about when you're coming up with solutions. How do you structure the data? How do you flow that workflow through to the actual consumer in a way that makes sense and is useful? So with all that being said, you can find me at GitHub. Oops. At PunkMap is my personal GitHub account. There's not a lot out there, but that AVL time thing is out there. It's CouchD3 time. You can find it there. Work Maps is where you'll find some of my work stuff. There's a really great, if you like CoffeeScript, there's a really great application out there that has a much better slider in it. And then I'm going to post this YouTube video up here. If you like beekeeping or walking dogs around historic sites, you'll like this. It's all 3D, or not 3D, 360. And with that, I'm going to conclude. Thank you.